Hi everyone, welcome back. So in the set 3 we have completed to 155 bits. Now let's start from 156 bit. This is our last set number 4. Okay, let's begin. The current which changes the direction after an equal interval of time. So if you observe the AC and the DC current, this is our AC current and this is our DC current. If you observe the AC, it will have positive half cycle, negative half cycle, positive half cycle, then comes negative half cycle. So for every equal interval of time, the direction of the current is changing. So we can say what it is a AC current. If you observe the DC, it is constant throughout the time period. So what will be our answer? Option number C is our answer. AC. Electric generator will have what? Slip rings. Okay. Now DC generator will have what? Two half slip rings, which is also called as split rings or commutator. Okay. So one is B and four is C. Let's see which is our option. Only one option starts with B, that is our answer, option number A. Now, principle involved in dynamo. Dynamo is nothing but what? Generator. Generator works on the principle of what? Whenever there is a change in the flux, an induced EMF or current will be formed. So, what is that? It depends on electromagnetic induction, and this is the law explained by a scientist called as our Faraday. Faraday. Okay, so electromagnetic induction. Let's see the next question. Now, the role of commutator in the DC motor is, they have asked, the direction of the current through the coil reverses for every half of its rotation. That is correct only. P is correct. Let's see the second question, second option Q. Direction of the current throughout the coil is reversed for every one revolution or one rotation. That is wrong. Every half of the rotation it changes. So Q is wrong. P is correct. Let's see the R. It helps the coil to move in the same direction. That is correct only, right? If you take a motor here, now whatever the coil it is there, it will be rotating in one direction, right? So every half of the rotation only the current direction changes, but the coil will be rotating one direction. So what we can say that P and R is correct. P and R is correct means which option? Option number C is our answer. Okay, let's see the 160th bit. Magnetic field exists in all direction around the bar magnet. Is that correct? Yes. If you take any magnet, you consider bar magnet, magnetic field will be present surrounding the bar magnet. So you can see that it is a three-dimensional magnetic field around the magnet is a three-dimensional. So we can say that around the bar magnet in all direction magnetic field is present. So option number X is correct. What is the y given? Magnetic field is a three-dimensional. That is also correct. Just now I told. So X and Y is correct means which option? Option number A. Both X and Y are correct. Let's see the next question. The strength of the magnetic field between the poles of the electromagnet would be unchanged. So when it not get unchanged, if you observe the first question, material of the core of the electromagnet is changed, then it can be that magnetic field also changes. Direction of the current in the electromagnet winding is reversed. This is only correct because if you take any coil, if the current is moving in direction, only the polarity changes, but the magnetic field, strength of the magnetic field will be same. If it is with the current moving in the opposite direction, then the polarity will change. Only the polarity changes, but the strength of the field will be same. So what we can say that direction of the current in the electromagnet winding is reversed. Then strength of the magnetic field will not change. Okay. 162. When Ramu is riding a cycle fastly, bulb is glowing. And now in today's bicycle, you cannot see it. In olden days, whatever the bicycle is there in front of the bicycle, bulb will be fitted. So it is connected to a small device called as dynamo. Okay. So dynamo is nothing but our generator. So bulb is glowing means what? It is our generator. Who invented electric generator? Electric generator is invented by a scientist called as Michael Faraday. Option number D is our answer. 164th bit. Which one of the following can produce maximum induced EMF? Induced EMF only form when there is a change in the flux, means d phi by dt. Then only EMF will be induced. Means there should be a change in the flux, means so there should be a change in the current, so it should be an alternating current. If you observe here, option number B and option number D, we can cancel it because they have given DC means direct current. Constant current means there will not be any change in the flux. So if you observe A and C, if you observe the A, 500 hertz. Hertz means what? Frequency. Nothing but number of cycles per second. If number of cycles per second is more, then more amount of induced EMF will be present. So what we can say, our option number A is our answer. The most suitable material to make a core of the electromagnet, that is will be our soft iron. Soft iron. Okay, that page is over. Let's see the next page. Let me zoom it. The magnetic lines of force inside the current carrying solenoid. As I already told, if you take any solenoid outside the bar magnet, what we can observe that it starts from north pole and then it's at south pole, and outside the bar magnet or solenoid, the magnetic field will be non-uniform. But when it reaches the ends, inside the solenoid, all the magnetic field will be moving parallelly. Parallelly means what? It is a constant. So magnetic field will be constant inside, or uniform magnetic field will be present inside the solenoid, but outside it will be non-uniform. What is the question given there? Inside the current carrying solenoid, if you observe the first option, along the axis parallel to each other. That's what we have drawn now. Magnetic field will be parallel to each other. Option number A. In electromagnetic induction, the induced EMF is independent of. Induced EMF means what? d phi by dt. So change in the flux is nothing but our change in the flux. So we can say option number A is correct. With respect to time only, it is depend. Yes, Tesla is nothing but EMF. No, magnetic flux density. So Tesla is correct. Tesla. Then what is independent? We can say that Weber. Change in flux should be present. Okay, option number B is our answer. Let's see the 168th question. The direction of the magnetic field at a point due to infinitely long wire carrying current. So direction of the magnetic field will be what we can say, it will be perpendicular to each other. So what we can say, perpendicular to the plane containing the conductor and the point. Option number B is our answer. 169th question. A soft iron bar is inserted inside a current carrying solenoid. The magnetic field inside the solenoid is, they have said. So if you take any solenoid and through the solenoid current will be passing, again current is passing means what? Here one magnetic field will be present already. When we bring a bar magnet, when we pushing this bar magnet into the coil, there what we can observe that there will be a change in the flux. Change in the flux means that there what happens, there will be an increase in the field. So what will be our answer? Will increase. Option number B. To convert mechanical energy to electrical energy. So you are getting electrical energy means what? It will be a generator. You're producing the electrical energy means it should be a generator. So dynamo or generator are same, so it can be a DC generator or it can be AC generator, both A and B. Option number D is our answer. So let's see the 171st question. If the direction of the electric current in a solenoid when viewed from a particular end in an anti-clockwise direction, so solenoid, if you observe, there is a rule called as clock face rule. Clock face rule. According to it, if you draw as n like this, so if you observe, this is the direction of what? Current. If it is anti, this is telling about anti-clockwise direction. If it is anti-clockwise direction, it shows the north pole. So number D. If it is south pole, should be drawing like this. So when the current is clockwise direction, then the phase will be south. So here anti-clockwise means north. See, as I already told that our Zoom class starts from 19th. Those who are really interested, they can join our WhatsApp group. Link is given in the description given below of this video. Those who are really interested, for them only, those who are entering into this Zoom classes, they will be only getting this ID and password, and along with that, for the grantors, we'll be providing separate passports. All those things will be given. So those who are interested, they just join. So we'll be having certain charges. No, sir. We don't want any charge. We'll be reading in free of cost. Means you can have. I think many YouTube videos are already present in the YouTube. You can go there. But the only thing is that our schedule start from the afternoon from 1 o'clock to 5 o'clock. There will be a continuous class. This schedule will not be present anywhere if whatever the videos you are observing in the YouTube. Every channel will be uploading maximum 1 or 2 videos. 1 or 2 videos enough for a day. If you think it, If you invest certain amount of money now, you're investing for your life. Your life will be settled. Okay. As I said, there will be a continuous class for us from 1 o'clock to 5 o'clock. I think it starts from Max 1, then Physics, then Max 2, then Chemistry. If Biology is there, then one more period will be added. Continuous class. Okay. See if you, as I already told that if you really want to achieve a seat, you can join to our WhatsApp group. We join to our class by through our WhatsApp group link, okay, which is given below. Oh, sir, we can read by ourselves means it's up to you. But only thing that when you read by yourself, there will not be any particular time schedule. Whatever the time, free time you get, that at that time only you'll be learning it. And whatever the thing they say in the other videos, you'll be watching that. Is that enough to get a seat? I think you know that seat is limited. Only 4,000 seats are there, and many number of students will be applying for it. Just by watching it, these one or two videos in the YouTube, are you thinking that you can get a seat? You just think it. Think seriously and take a decision. Okay, I don't force anyone. It's up to you. If you really want to get a seat, you just join to our class. Okay, let's continue. Don't want to waste your time. The magnitude of EMF produced in the coil when the magnetism is inserted does not depend on. So, magnitude of the EMF does not depend on. This question was already asked. Repeat. I think in the set one, answer is magnetic moment of the magnet. North and south polarities of the electromagnet can be found easily by using what rule? North and south polarity. Just now I said clock phase rule. It is anti-clockwise direction. It is our north. It is clockwise direction. It is our south. So clockwise rule. Option number C. Let's see 174th question. X, the induced current will appear in such a direction that it opposes the change in the flux. That is correct one. That is called as our Faraday's law. Okay, the second question what they have given, the induced current will appear in such a direction that it supports. That is wrong. It opposes. So X is correct, Y is wrong. Option number C. 175th bit, mathematical form of Faraday's law. We know that E is equals to d phi by dt. So if you observe that this option is not given, you bring this dt to left side become what multiplication. So what we can write here, d phi is equals to E into dt. So here they have given in delta, sir. See, delta and d is similar. Delta is a change. When we will be using the delta? When there is a large change in the flux. When there is a small change in the flux, we will be using a d sign. Okay, so option number C is our answer. 176th bit. The essential difference between AC generator and DC generator. We have seen that AC generator will have slip rings, and DC will have what? Split rings, which is also called as our commutator. So which is our option? I think yes, option number D is our answer. So that page is over. Let's see the next page. Let me zoom it. Okay, 177th question. X. In electric motor, mechanical energy is converted into electrical energy. In motor, mechanical to sorry, electrical to mechanical will takes place because motor means what? The coil will be rotating. Rotating means what? Mechanical energy. So electrical to mechanical takes place. They have given mechanical to electrical. So X itself is wrong. In dynamo means what? Generated. In generator, electrical energy should be generated. So if they have given what they have given mechanical energy, that is wrong. So X and Y both are wrong. So option number or B, X and Y are incorrect. A magnet is placed vertically on a paper. The number of neutral points. I have already said this question in set A. Only one neutral point. That is our option number B. Okay. Let's see the 179th question. Right hand thumb rule. Okay, right hand thumb rule tells about what direction of the magnetic field. Okay, direction of magnetic field. Biot-Savart's law tells about what this law you'll be learning in higher classes. It is our magnitude of magnetic field. Okay, so CA. Where is that option? Any option is that CA? Only one option start with C. So that is our first option. CA option number A. Okay, 180th bit. A small magnet is placed perpendicular to the uniform magnetic field. The force acting on the magnet will result in. This will result in what? This will result in the rotational motion. Okay, option number A. Option number A. Then comes our 181st question. Loop of wire in motor rotate because loop of wire in motor rotate. Why it rotates? Because a force. If you observe this loop, current is moving like this and current is moving like this. The force will make the coil to rotate. So magnetic force exert a force on the loop causing it to rotate. Option number A. So what is the rule will be used here? That is our Ampere's right hand thumb rule. Right hand thumb rule. Okay. 182. The end point of the solenoid where the current appears to be flowing anti-clockwise. Just now we have seen. If you write the end like this. So anti-clockwise means so that it should be our north pole. Option number C. The magnetic force on a current carrying wire placed in a uniform magnetic field if the wire is oriented perpendicular. What is the formula? F is equals to, if it's a current, our formula is Bill sine theta. Now they have given perpendicular means theta is 90, sine 90 is what? 1. So what we can say here, it gets cancelled. So what is left? Bill. F is equals to Bill. Option number B. 185th question. A vertical wire carries a current forward, then the magnetic field of the wire will be directed upward. So, oh, sorry, not forward, upward. Okay, vertical wire carrying current upward, so the magnetic field in a wire will be directed. What is that option given there? Upward they have given, eastward they have given, westward they have given, and northward they have given. So, what is that? Vertical wire carries a current upward they have given. Okay, okay, upward means what we can say that out of page means upward means what out of page. Out of page means the magnetic field will be moving in which direction. Anti-clockwise means it should be our west direction, westward. Option number C. A current carrying loop lying in a magnetic field behaves like a uh, like a magnetic dipole. So what is the dipoles are? Two poles. For every magnetic they will be having two poles, right? Those are called a dipole. So current carrying conductor produce magnetic field, so that conductor will act as a magnet, which will have two poles. Dipoles is called as a dipole. Magnetic dipole. Option number A. Okay, next page. Mhm. No force acting on a current carrying conductor when it is placed what? When it is placed parallelly, think that this is our conductor. When a conductor is placed parallelly, what happens? No magnetic field is passing through it. So what we can say that when there is no magnetic field passing through it, no, so no effect of force can be present on the conductor. So what we can say that parallel to the magnetic field. When a charged particle moves through a magnetic field, suppose a charge in its direction, change in its what? That is called, that's what we will be seeing in the distortion of the TV screen. So direction of the motion of the electron, charged particle. 189. A straight wire is carrying on an electric carrying current. If it is a straight wire, current will be, or if it is a straight wire, magnetic field will be formed as a concentric circles or circular lines. So what is that? You can say first option is right. I think the lines of force, they are circular lines encircling the wire. Option number A. 190th question. No force works on the conductor carrying current when it is placed. Just now I said parallel to the magnetic field. Option number A. Now 191 question. A charged particle Q is moving with a speed v perpendicular to the field of induction V. Then the which of the following is correct? Force will be acted or directed perpendicular to the velocity. That is correct only. Perpendicular it will be acting. Second point what they have said, particles moves along the circular path. Okay, circular path only. It will be moving circular path only. Now third point what they have given, radius of the path is 2 pm by dq. It is not 2 pm. Radius of the path formula is what? mv by bq. What is the time period formula? 2 pi m by bq. So radius is wrong, time is wrong. So 1 and 2 are correct. Which option? Option number D is our answer. Let's see the next question. 192. A positive charge body is projected in the east direction. Okay, east direction. Now charged particle deflect towards north. So deflect towards now the direction of the magnetic field they are asking. What is the direction of the magnetic field? West, south, vertically upwards, vertically downwards. So what will be the answer? This question is already being asked in set 1. That is our option number downward, D, vertically downwards. Now 193rd question. A horseshoe magnet's two poles are kept on both sides to current carrying conductor in this experiment direction of the force. How we can find the direction of the force? Only a certain rule. So what we can say that wire deflects according to right hand thumb rule. Okay, 194th question. The phenomenon of electromagnetic induction is. So what is that? On what basis? When the current will be or current or EMF will be induced when there is a relative motion between the magnet and the coil. Relative motion means what? Either you can move the coil or we can move the bar magnet. If you move both also, an EMF will be induced in the coil. So relative motion between the magnet and the coil, option number C is our answer. 195th question. The magnet is moved towards a coil first quickly then slowly. So induced EMF. See if it is moving quickly, bar magnet is moving quickly into the coil, what happens? More amount of EMF will be induced. If it is moving slowly, less amount of EMF will be induced. What is the option given there? Larger in or smaller? Larger or smaller, not what? That is wrong. Equal in both cases, wrong. Larger in the first case, yes, correct. If it is moving quickly, larger in the first case. Option number C is our answer. So 195 questions over. Let's see the next page. This is our last set. As I already told, I'll be covering more than 200 bits. A current flows in a conductor from east to west, the direction of the magnetic field in a point above the conductor. So east to west they have said. Okay, east to west means what? We can say it will be directed towards the north. Which of the following correctly describes the magnetic field near a long straight wire? Okay, in a long straight wire. So just now we have seen few minutes back, if it is moving, if it is currently moving in a long straight wire, the magnetic field will be what? Concentric circles. So what is our answer? I think option number D is our answer. Field consists of concentric circles. 198. An MCB which cuts off electricity supplies in case of short circuiting or overloading works on. MCB means what? MCB is nothing but miniature circuit breaker. Okay. This miniature circuit breaker is being replaced with the fuse. In fuse, what is the disadvantage? If the wire melt, we should manually remove the fuse and we had to change the wire. But in the miniature circuit breaker, it's automatically, if overcurrent flows through the circuit, it automatically switch off. Okay, that is been advanced. That is the reason we will be nowadays fuse is being replaced with the MCB. Now, based on what? Based on the based on the what? Magnetic effect. Magnetic effect on the current. Option number C is our answer. The magnetic field inside the long straight solenoid carrying current. Inside means what? It, as I already told you, all the lines will be moving parallelly. So it will be uniform field. So what will be our answer? Same at all points. Option number D. 200th question. A circuit breaker device which can be used in place of fuse in domestic electric. Just now I said is our MCB, miniature circuit breaker. A magnetic field at a point due to the current carrying conductor is directly proportional to. Directly proportional to what? That's not current only. The current carrying conductor produces magnetic field. That's what the conclusion what the oyster said through the oyster experiment. So option number A. So 202 question. A charged particle is moving through the uniform magnetic field. Uniform magnetic field. So uniform magnetic field means what? There will be no change in the magnetic field. Whenever there is change in the flux, then only current will be induced. So when there is no change in the field, what happens? There will be no force on the particle. Never exerts a force on the particle. 203. Which of the following is not true? Yes. What is that answer? I think this question is already asked in set 1 or set 2. Option number D. Permanent magnet retains its magnetism even it is heated. We already know that if any magnet, if it is heated, it will loses its property, magnetic properties. If it is any magnet, so if it is a permanent magnet also, it will lose its property, but they have given that it will retain. So option number D is our answer. 104. Okay, an induced EMF produced when a magnet is inserted in the coil does not depend on what? The speed of approach of the magnet. Option number B. Sorry, let me drag upwards. The condition necessary for electromagnetic induction. Now, just now we have seen there should be a relative motion between the magnet and the coil. If they have given galvanometer and the magnet, that is wrong. Coil and the galvanometer, that is wrong. Okay, there should be a relative motion between the coil and the magnet. That will be our answer. Option number B is our answer. So 105 over. Let's see the next page. Last page. Yes. Now see the question from the following figure. Okay, the lines are imaginary lines called as electric field. Is it electric field lines? No, magnetic field lines. So option A is wrong. Lines are imaginary lines called as magnetic field lines. That is correct. The fields are strong when the lines are crowded, and fields is weak when the lines are apart. Yes, at the near to the poles, all the lines gets crowded, so there the field will be more. At the middle region, the field will be less. So option number A. What is that? B and C. What about the D? Field is weak when the lines are crowded. That is wrong. So BC is our answer, which is our answer option number B. Okay, 207 from the figure what they have given. This curve shows the relation between the flux and time. Okay, now at which time interval EMF is not induced? EMF, when the EMF is not induced, when there is no change in the flux. When there is no change in the flux, there will be no induce of EMF. So if you observe here this region is constant, this region is constant. When there is a constant flux, there will not be any induce of EMF or current. So 2 comma 4 and 5 comma 7. What is that? 5 comma 7, yes, 5 to 7 and 2 to 4. So both A and C. Option number D. 208. Okay. Now the magnetic field lines are represented as, okay, 1 and 2. What is that? A. 1 is a uniform magnetic field. Yes, that is correct. B. 2 is a non-uniform magnetic field. That is correct. C. 1 is a non, that is wrong. This is also wrong. So A, B is correct, which is our option. Option number D. Let's see the next one. According to the Fleming's right hand thumb rule, right means generator. So as I said, Ampere's right hand thumb rule, what about the middle finger and the forefinger is there? These are forefinger and these are middle finger. Forefinger and poor thumb tells about the force. Forefinger tells about the current and middle finger tells about the magnetic field. But in the Fleming's, these two factors will be interchanged. What we can say that, let's see the options. Okay, I think option one minute. This is wrong. Okay, and D is also wrong. On based on these two, we have to say. Just now I said that forefinger tells about the direction of the magnetic field. So I think C is our answer. Okay, sorry. B. Thumb tells about direction of motion. Forefinger tells about direction of magnetic field, and the middle finger tells about direction of current. Option number B. He just reversed his hand. That's all. Now last question of this set 4, 210 questions I have covered. So they have given the figure diagram shows a bar magnet surrounding a 4 floating compass. Direction of the magnetic field. By using this compass, we have to say in which direction magnetic field is present. If you observe here, like this, it is moving arrow mark. Yes, means what is that? North to south only. North to south. So what is our answer? X is our north and Y is our south. Option number C. So with this we have completed 210 questions. So 200 plus questions also I have covered from this chapter, electromagnetism. So as I already told that the concepts we will be discussing in our Zoom class, and along with that all the mock tests, whatever I'm keeping in the group, that one maybe after this 19th of October I won't may keep in that. So those who are very much interested, you just join the class. There we'll be discussing more bits, more grand tests will be conducted on full syllabus. So in the whatever the mock test I'm conducting is just for the 30 marks I'm conducting 30 bits based on physics and chemistry. That is not enough. So there are max. So on the full syllabus we'll be getting the grand test. That too timed grand test. Okay. So those who are interested, just join the class. I don't want to force anyone if you're really interested. So this is Madhu Mahesh Raj signing off. Bye.